Hello, my name is Sierra Bolton, and today is December 15th, 2023. So for case number 1, we had a newborn girl that presented with symptoms of lethargy, hypothermia, and apnea. Lab results showed that she had high blood ammonia that was rapidly rising, as well as high levels of urinary orotic acid. However, her plasma citrulline levels were normal. To go over ammonia transfer in the body, excess amino acids are brought to the liver where they are oxidatively deaminated, forming ammonia, which is combined with carbon dioxide to form urea in the urea cycle. This urea is a less toxic way of transporting nitrogen, and it is filtered out through the kidneys in the urine. The non-toxic nitrogen carriers in our bodies are amino acids alanine and glutamine. Transamination reactions help in this process because they transfer amino groups between amino acids and keto acids, forming new amino acids and new keto acids. Not only does this help to regulate levels of nitrogen as it assists in nitrogen disposal, this helps to regulate the levels of amino acids and keto acids, as well as to provide energy for the body as pyruvate is produced. Aminotransferases include ALT and AST, and they require the cofactor peroxidyl phosphate. So in most tissues, glutamate is combined with the ammonium ion to form glutamine. This requires ATP and glutamine synthase. Most of the ammonia in our bodies is present as the ammonium ion. In the liver, this glutamine is then oxidatively deaminated. First, it is deaminated to form glutamate through the glutaminase enzyme. And this glutamate is then deaminated once more to form alpha-ketoglutarate. This can also produce NADH or NADPH and utilizes the enzyme glutamate dehydrogenase. The excess ammonia is then excreted through the urea as previously discussed. In the muscles, we have a transamination reaction going on between glutamate and pyruvate. This forms alanine, which then reacts with alpha-ketoglutarate in another transamination reaction to form glutamate and pyruvate. This pyruvate, during times of fasting, is used in gluconeogenesis as a carbon skeleton source. This produces glucose, some of which goes back to the muscles in what is known as the alanine glucose cycle. To go over the production of orotic acid in the urine, carbon dioxide and ammonia are combined to form carbamyl phosphate through carbamyl phosphate synthase 1 and the use of ATP. This carbamyl phosphate can either undergo pyrimidine synthesis, where it forms orotic acid that can be expelled through the urine, or it can form citrulline through the ornithine transcarbamylase enzyme. This citrulline can then undergo several reactions to form arginine. I believe that the most likely enzyme in the urea cycle to be affected is the ornithine transcarbamylase enzyme. This is because if this enzyme is deficient, then we have an accumulation of carbamyl phosphate, which would lead to an accumulation in orotic acid being produced, and the patient had high levels of orotic acid in her urine. In this case, we would normally expect a decrease in citrulline, and the patient did not have a decrease in citrulline. However, this could just mean that the body has compensation reactions, such as producing less arginine from the available citrulline, preserving its concentration levels. In this case, arginine arginine would become conditionally essential. I believe the least likely urea cycle enzyme to be affected would be carbamyl phosphate synthase 1. That's because if there was a dysfunction in this enzyme, this would lead to a decrease in carbamyl phosphate, which would lead to a decrease in orotic acid, which is the opposite of what we saw presented in our patient. So in case 3, a man was diagnosed with gout. His lab results showed an increase in plasma urate and a decrease in urinary uric acid. We're going to explore 3 different possible causes. One is purine overproduction, the second is a decrease in purine salvage, and the third is a decrease in the excretion of uric acid in the urine. So for the first possible cause, I do not believe that he suffers from an overproduction of purines. Purine nucleotides are broken down into their respective bases, which are then deaminated or oxygenated to form xanthine, which is then oxygenated to form uric acid, which is expelled through the urine. Therefore, if we had an overproduction of purines, this would lead to an increase in the xanthine being produced, which would lead to an increase in uric acid in the urine. However, we found a decrease in urinary uric acid. If we were to find an increase in uric acid as expected in the overproduction of purines, then this would explain the increase in plasma urate because uric acid, as it dissolves in the blood, forms urate ions. So for the second option, I do not believe that the patient suffers from a decrease in purine salvage. Purine salvage are where purine bases are converted back into nucleotides in order to decrease the production of uric acid. If we had a decrease in purine salvage, that would mean that more of the bases were being degraded into uric acid, and we would expect once more an increase in urinary uric acid. This does not correlate to the patient's symptoms. However, if there were an increase in urinary uric acid as expected, then this would explain the increase in plasma urate as previously discussed. So for the third possibility, I do believe that this patient has a decrease in the excretion of uric acid in the urine. One potential cause of this is excessive alcoholic consumption, and this is because alcohol and uric acid compete for excretion in the kidneys. If there was a decrease in excretion of uric acid in urine, then this would clearly lead to a decrease in urinary uric acid. This would also lead to an increase in uric acid in the body as it accumulates, which would lead to an increase in plasma urate as it dissolves into the blood. So the patient then shared that he drinks between 4 to 5 liters of soda a day. This means that he likely has a very high intake of fructose, as fructose is very concentrated in soda. Fructose is metabolized into glycerin 3-phosphate, which is used to produce ribose 5-phosphate in the phosphate pentose pathway. This ribose 5-phosphate is used to produce the activated 5-carbon sugar, PRPP, which is used to produce purine nucleotides. These purine nucleotides, as previously discussed, are broken down into uric acid. Uric acid has low solubility in the body, so a high concentration of uric acid would lead to the formation of urate crystals. These crystals tend to form in patients' joints, This would cause inflammation and pain, which would ultimately exacerbate the symptoms of gout that the patient experiences. Thank you.